This is a video for the Chapter 36 lab, which will be in week 16 of a fall and spring section, or in week 8 if you're taking this in the summer. And we see you need to open, save, and print table 36. We're going to run volume 2, okay? And it's volume 2. And we want to be in modern. And we want to be where in modern? Time dilation. Am I not seeing time? Oh, there it is, time dilation. Okay, well, we'll just turn this guy on and run him a little bit. I guess we can't do that. We'll switch over to the information tab, let you read that while I go and figure out what the procedure is. Okay, we're going to click on the spacecraft, and I see that the people are moving to the left, so that's good. I'm going to set my relativity speed at 0.1, the speed of light. Okay, 0.1, the speed of light. And then I'm going to fire the laser. And I'm going to record, what am I supposed to record? The distance and the time. So I have a distance and a time sitting right there. Okay, and then I'm going to go to 0.25. And I'm going to fire the laser. And I'm going to record the distance and the time. And then I'm going to go to 0.5, half the speed of light, fire the laser, and record both the distance and the time. And then I'm going to go to 0.99, the speed of light, because this is getting pretty boring and nothing's changing. And I'm going to fire the laser. And everything stays the same. And then I'm going to go, and that's run 1. So one run is complete. Moving on to run 2. I'm going to click on, we'll reset, pause, we'll do something. I'm going to click on the people. Reset up there. Okay, so we're going to click on the, didn't I click on the people before? Click on the people. Okay, so now the spacecraft is moving and the people are watching it. On the first set of data, what you're doing is you're standing in your spacecraft measuring how far your laser was moving. Now we're going to drop down to 0.1, the speed of light. Okay, we're going to fire our laser. And we're going to record the distance the laser traveled and the time that the pulse took to do it in the reference frame of the people sitting on the ground, what they saw. Then we're going to go to 0.25, the speed of light, and do it again. Well, maybe we won't. We'll fire the laser when the spacecraft is in view. Okay, there we go. I'm going to fire the laser, and we've got a total distance, and we have a time for the laser. And we're going to go up to 0.5, half the speed of light. And we're going to fire the laser. I don't have to wait for it to come into view, but I'm going to wait anyway. Okay, we're going to fire the laser. And there we have another distance and speed of light for you to record. 0.9 the speed of light. And we're going to fire the laser. And we have a speed and a distance and a time to record. I'm going to go to 0.95 the speed of light. And we're going to fire the laser. And we have a distance and a speed. We're going to go up to 0.99 the speed of light and do it again. And almost made it back. Okay, so now we have a distance that light traveled and the total time of the laser pulse. Okay, so that ends run number 2. So now we're going to come to run number 3. You do have some calculations to do there. Okay, we're going to click on menu. I'm going to get out of here. Menus, boom. And we want length contraction. Length contraction. Found it. Okay, length contraction. I'm going to click on the train station. Boom. Okay, so I'm looking at the train station. And I want to set the relative speed at 0.1 the speed of light. Okay, so there we are. And now we have, what are we supposed to record? We're supposed to record the diameter of the disc on the ground and on the train. And we can see it right there, sitting right there. And then we're going to go, and before we go to the next one, we're going to hit this information guy so you can read it if you need to. You're going to have to pause it because I'm not going to stay there too long. All right, we're going to come up to 0.3, the speed of light. And then record the disc on the ground and the disc on the train. We're going to go to 0.6, the speed of light. And we're going to record the size of the disc on the ground and on the train. 0.9 the speed of light. Record size of the disc on the train and on the ground. 0.95 the speed of light. Do the same thing, make the same discovery, and 0.99 the speed of light. And record both the diameter of the disc on the ground and on the train. You have calculations to do, and then we go on to run number 4. So we're going to click on menus, and we're going to click on Wilkinson Morley experiment. I'm going to set the speed of the ether wind at 50 kilometers per second. Okay, 50 kilometers per second. And then we're going to rotate the disc. I'm going to measure the number of minor divisions expected and observed. All right, so there's expected. This is what we're seeing. Now, what's a minor division? See the big long red line? See the big red line? That's a major division. So a minor division are these smaller little lines. So right now I see 0 and 0. There's no difference between this guy and that guy. I'm observing nothing, which is good. I'm going to change to 30 degrees. And I see my observed hasn't changed any, but I have shifted and I got some minor divisions here. Now I wasn't paying attention during that shift. Okay, so I'll go back and pay attention to it during the shift. And now I can see that it used to be in the middle of the sky, and now I've got that many minor divisions. I'm going to move it again to 45. And the number of observed divisions, I didn't think that changed much, so it's not going to change much. But I do have some minor divisions that I've moved. Okay, I'm going to, on the expected one, I'm going to go to 60. Okay, now I'm at 60. Observed hasn't changed any, but I have a significant amount of change there on the number of minor divisions. And when I come up to 90 degrees, do it again, I end up observing no change here, but I do have a lot of change there. So we'll have to figure out what that guy is. Okay, that's for you to figure out. That ends lab number 36.